Right now, as you watch this video, your device is processing millions of bits of information every single second. You've heard terms like gigabytes and terabytes thrown around, but do you really know what they mean? Today, we're diving deep into every data unit explained, from the tiniest bit that represents a single 0 or 1, all the way to units so massive that all of human knowledge barely scratches their surface. Here's the mind-blowing part. Every photo you've ever taken, every video you've watched, every message you've sent, it all started with just those two numbers. Stick around because by the end of this video, you'll understand the complete hierarchy of data storage and exactly how much information humanity has created and where we're headed next. The foundation: understanding binary. Before we dive into gigabytes and terabytes, we need to understand how computers actually think. Unlike us, computers don't count using 10 digits. They use just 2, 0 and 1. Why? Because at the most fundamental level, computers are made of billions of tiny electronic switches, and switches have only two states, on or off. This is called the binary system, and it's the foundation of everything digital. Number 1, the bit. Meet the bit, short for binary digit. This is the absolute smallest unit of data a computer can process. Think of it as a single light switch. It's either on, 0, or off, 1. That's it, just two possibilities. Now, a single bit might seem useless on its own. After all, what can you really do with just an on or off signal? But here's where it gets interesting. When you combine multiple bits together, you create patterns, and these patterns can represent anything: numbers, letters, colors, sounds, even entire movies. Number 2, the nibble. Group 4 bits together and you get what's called a nibble. I know it sounds like a snack, but it's actually quite important. With 4 bits, each having two possible states, you get 2 to the power of 4, which equals 16 different combinations. So a nibble can represent 16 different values, from 0000, which equals 0, all the way to 1111, which equals 15. You might be wondering, when would I ever need to know about nibbles? Well, nibbles are crucial in programming because each nibble perfectly corresponds to one hexadecimal digit. In hexadecimal, a base 16 counting system used in coding, the binary sequence 1010 becomes simply the letter A, and 1111 becomes F. Number 3, the byte. Now we're getting to something you've definitely heard of: the byte. 1 byte consists of 8 bits, or 2 nibbles. Using our binary math, that's 2 to the power of 8, giving us 256 possible combinations. This is huge because 256 different values are enough to represent every letter in the alphabet, both uppercase and lowercase, all the numbers, punctuation marks, and special symbols. In fact, when you type the letter A on your keyboard, your computer stores it as the binary pattern 01000001, exactly 1 byte of data. Here's a practical example. If you send a text message that says hello, you're using approximately 5 bytes of storage, 1 byte for each letter. Number 4, the kilobyte. Here's where things start to get interesting and also a bit confusing. You might think a kilobyte would be exactly 1,000 bytes, right? After all, kilo means 1,000. But in the computer world, 1 kilobyte actually equals 1,024 bytes. Why the weird number? It all comes back to binary. Computers work in powers of 2, and 2 to the power of 10 equals 1,024. This is the closest power of 2 to 1,000, so computer scientists adopted it as the standard. 1 kilobyte can store roughly 1 page of plain text, about a short paragraph or a simple email. Back in the 1980s, entire video games fit into just a few kilobytes. The original Super Mario Bros., less than 32 kilobytes. Today, that's smaller than most email attachments. Number 5, the megabyte. Scale up by another factor of 1,024 and you reach the megabyte, roughly 1 million bytes. Technically, 1,048,576 bytes. 1 megabyte can hold a short MP3 song, a small photo from your phone, or about 500 pages of plain text. In the 1990s, floppy disks held 1.44 megabytes, which seemed like plenty at the time. Now, a single high-quality photo from your smartphone can be 3 to 5 megabytes. Number 6, the gigabyte. Welcome to the gigabyte, the unit most familiar to anyone with a smartphone or laptop. 1 gigabyte equals 1,024 megabytes, or roughly 1 billion bytes.
A gigabyte can hold about 250 MP3 songs, around 300 high-quality photos, or approximately 30 minutes of HD video.
When you buy a phone with 128 gigabytes or 256 gigabytes of storage, you're measuring in gigabytes. Most modern laptops come with at least 256 gigabytes of storage, while high-end models might have a terabyte or more. Number 7, the terabyte. Step up to the terabyte, and we're talking serious storage, over 1 trillion bytes. 1 terabyte can hold approximately 250 full-length HD movies, 6.5 million document pages, or about 200,000 songs. External hard drives with 1 terabyte or 2 terabyte capacity have become standard for storing large media libraries, backing up computers, or working with video editing projects. For most people, a terabyte of storage is more than enough for everyday needs.
Number 8, the petabyte. PB. Now we're entering territory beyond personal use. A petabyte equals roughly 1 quadrillion bytes. To put this in perspective, 1 petabyte could store about 13 years of HD video, or 10 billion photos. Large tech companies measure their data in petabytes. Google processes over 20 petabytes of data every single day. The entire Netflix library? Just a few petabytes. Academic research institutions, cloud storage providers, and major corporations all operate at this scale. Number 9, the exabyte, EB. An exabyte represents more than 1 quintillion bytes. That's a 1 followed by 18 zeros. At this level, we're talking about truly massive amounts of data. All the words ever spoken by human beings throughout history could theoretically be stored in just 5 exabytes. The entire internet traffic for a day worldwide, now measured in hundreds of exabytes. By some estimates, all the data created in human history up until 2003 totaled about 5 exabytes. Today, we create that much data every single day. Number 10, the zettabyte, ZB. We are currently living in the zettabyte era. 1 zettabyte equals over 1 sextillion bytes. Try to wrap your head around that. It's 1,000 billion bytes. According to recent estimates, humanity collectively generated around 120 zettabytes of data in 2023, and that number is growing exponentially. Every photo uploaded to social media, every video streamed, every email sent, every GPS location tracked, it all adds up to hundreds of zettabytes of data. The future. What comes next? The yottabyte, YB. By 2030, experts predict we'll enter the yottabyte era. 1 yottabyte equals roughly 1 septillion bytes. This number is so astronomically large that no storage system on Earth can currently handle it. To give you perspective, if you could somehow store 1 yottabyte on standard hard drives, you'd need billions of them, and they'd cover an area larger than several football fields. The exponential growth. Here's the truly mind-blowing takeaway. The amount of data humanity creates isn't just growing, it's accelerating. We created more data in the past 2 years than in all of previous human history combined. With artificial intelligence, the Internet of Things, virtual reality, and technologies we haven't even imagined yet, this trend will only continue. Every like, every click, every sensor reading, every AI interaction, it's all data. And it's all being measured in units that didn't exist just a few years ago. So the next time someone asks how much storage space they need, remember, it all starts with a single bit, a simple 0 or 1. And from that humble beginning, we've built a digital universe that now measures in the zettabytes and is racing toward the yottabyte era. Thanks for watching. If this video helped you understand the secret language of data, make sure to like and subscribe.